Okay, this is the overview lecture for chapters 11, 12, and 13, which covers landing and takeoff performance. And I'm going to go over some key definitions and equations here. Rate of sink is going to be equal to 101.3 times the velocity times drag minus thrust divided by weight, and this is going to be in feet per minute if you want to find the rate of sink. If you look at landing performance, when we draw this out, aircraft coming in to land, this is angles gamma. Say this dot's the airplane. Have lift. This is going to be total weight. This is weight cosine of this gamma angle, and this vector is weight sine of the gamma angle. So if we want to look at landing performance, we can say lift is equal to weight cosine of gamma. Drag is equal to weight sine of gamma. And then lift over drag would be equal to weight cosine gamma divided by weight sine of gamma. So that's the important part when you're looking at landing performance. Now you're going to see a lot of other equations here to compute how much power you need, those types of things, but this is the basic concept of landing performance. This vector here would be drag. Okay, if we look at takeoff performance, we can say a distance, and they're going to call it S, but it stands for distance, is equal to velocity squared divided by 2 times the acceleration. So this is not in knots, this is in feet per second, and this acceleration is in feet per second squared. So if you took those, you'd be able to find the distance that you need for takeoff. However, this isn't looking at any type of gravity or weight, so we can find what the acceleration is. We would do this: gravity times thrust minus drag minus total force divided by the weight. And this is on page 181. If we plug this in, now we've got an acceleration that looks at gravity and weight to give you a pure distance value for takeoff performance. If you look at page 182, there's a list there of factors that affect takeoff performance. Go ahead and take a look at that. And you'll also notice on chapters 11, 12, and 13, there aren't a whole lot of equations. It was the same way with chapters 8 and 9. But 11 and 12 and 13 specifically, there's a lot of reading there. So go ahead and make sure you just take a look at each of those chapters and skim over them. And I think doing the problems at the end of the book will also help you out. If you have any questions, please let me know. Thank you for your time.